Okay, we interrupted the lecture for a few minutes to iron out some details. So the last one we got through azimuths and bearings. Now I've drawn on the board a traverse. It's a 5-sided traverse. Okay, and I'm going to populate it with some dimensions and some angles, and this will be our traverse. We're going to take all the way to the end. So we'll be using this one from now on until through this lecture and through next lecture. So I've got some dimensions here, 382.20. I've got 368.28. I've got 579.03. And I've got 350.10. And given in this problem was also the interior angles. And the interior angles were as follows. 101.24. 16. 149.13, 16. Okay, 80.58, 46. . 116.19, 16. And 92.04. 46. That's all the interior angles. And we have to have the direction of one side, and that was given as north 51 22 00 east. So that's the azimuth of line AB and the bearing of line AB. It's in the northeast quadrant. Okay, we're going to take it from here. First thing we got to do is we got to make sure that we've got an interior set of angles that adds up to the proper number. And I'm going to draw the table we're going to be using over here. Okay? I'm going to go ahead and put points. Okay, AB 401.58. BC 382.20. 368. 579. And 350. Okay, when we get done, we're going to add those up because I need the perimeter down the road. And then we're going to look at azimuth. And azimuth of AB was 50.22. Okay, now our job today is going to be to figure out how to put in the directions of all of those guys. And what's going to happen then is we're going to find the XY component. And unfortunately, that's not the way you think. It's not called XY component. It's called latitude and departure. And this is the Y and this is the X. If you want to go back to your old way of thinking, A latitude is associated with northerling, and a departure is easterling. And notice that's the way we have them in our ordered pair, northeast. So this is actually the northerly one, and that's the departure is the X, or the easterly. Okay, so how do I do this? Of course, we're going to do the same thing we've done for years and years. We're going to take sine and cosine to find the XY components. So right here, I would take this. There's my XY components. This is the latitude. And this is the departure of vector AB. So it looks like if I take, and I know this angle, so it looks like if I take the cosine of that, I'm going to get the latitude. If I take the sine of that, I'm going to get the departure. And once again, that may be counterintuitive. It is, because you're used to using this angle. We're using the complement to that angle. So we end up with a latitude gives me the cosine, and the departure gives me the sine. So once I got that direction, if I take the cosine, multiply by the distance, I got the latitude. And if I take the sine and multiply by the distance, I have the departure. Okay, now I'm going to give you some advice. Some of you are going to take it, and some of you are going to throw it in the trash. If you draw this picture crappy, your work is cut out for you. Trust me. Draw it. You've got two little tools you could get in your hands real easy. One is a scale, and one is a protractor. They're worth their weight in gold. It'll make your life a lot simpler. Okay? I would do that if I was you. Some of you will and some of you won't. So, this is a progressive process. We're going to go from point A to point B to point C to point D to point E. If it's progressive, it means if you screw up, the air carries along with you. You can spend hours doing this and find out you screwed up the very first step, and everything you've done is a waste of time. Be accurate. Keep your data concise and available and recognizable. This chicken scratching is going to put you in a world of hurt. Okay, it will in the real world too, trust me. Part of my job was negotiating our way out of screw-ups, and most of the time it was because people thought, didn't write down, wrote shitty notes, couldn't pick them up and figure out what they did, and all of a sudden we're spending $50,000 to get ourselves out of a bind. Okay, we're going to go through this methodically. It's going to take a little while. Once I get through it, hopefully you've got I want you to get the concept. If you have the concept, it doesn't matter how many sides, it doesn't matter, nothing matters. Each joint is one little project, and you'll do it over and over and over again. You just got to keep the data in the right position so that you're not making mistakes based on transposition, not being able to read, miscalculation, and that sort of thing. So let's go about doing it. I'm going to show you what I do. You can figure out how you like it. If I was to do this, I would start with the known bearing or azimuth. You got to start with a known. I would draw an axis through that point. And the point I'm going to draw the axis through is point A. If I get myself a tool that will allow me to do that. That's the northerly and easterly coordinate system. Okay, I'm going to write down the date I know. That's what that angle is. And I'm going to erase this because I don't want it screwing me up. Okay, I'm going to be doing a ton of subtraction with degrees, minutes, and seconds. Okay, what happens if I start right now? I go off half-cocked. I start right now, and I go all the way around this thing, and I spend an hour doing it, and I find out that it didn't close angularly. I'll tell you what happened, you wasted your whole day. So the very first thing you need to do is make sure we have angular closure. So I'm going to write these down. 101, 24, 16. 149, 613, 16. 80, 58, 46. 116, 19, 16. 92, 04, 46. Okay, if these add up to the right number, I'm okay. If they don't, I've got to make adjustments, and I'm going to show you how to do that. I've got AB, BC, CD, DE, a five-sided figure. So my math tells me that if this thing is done properly, I should have 540 degrees. Okay, let me do the math. I'll show you what I do. I do the last column all by itself, and then I move things around. So I don't know how you do it, but I'll take 16 plus 16 plus 46 plus 16 plus 46 and add them together. I get 140. Then I take 24 plus 13 plus 58 plus 19 plus 4. Okay, I got 24 plus 13. 24 plus 13 plus 58 plus 19 plus 4. 118. And I'll take the last one. 101. 149. 80. 116. 92. Okay, degrees, minutes, seconds. 2 minutes has 120 degrees in it. So I can take 120 from this and put the 20 left over, put the 2 over here and make that 120, make this 538. 2 minutes is 120 minutes is 2 degrees. 60 minutes in a degree. 2 60s is 120. There's what I figure I've got invested in those 5 angles. 540 degrees, 0 minutes, and 20 seconds. Well, the 20 seconds has got me in a bind. Okay, I got to subtract 20 seconds from this mess. How do I do it? It's simple. Take the number of seconds that you're off, divide by the number of sides. Each of the angles now needs to be reduced by 4 seconds. So all I do is wander around here and change each one of those by a minus 4 seconds. So 16 minus 4 is 12. 16 minus 4 is 12. 46 minus 4 is 42. 12. 42. By doing that now, I have changed it so all of the angles close angularly. So all you do is add them up, find out what they should be, subtract the two. If there's a difference, make the correction. If there is no difference, continue on. Once there's a difference, find out whether you have to add or subtract, and divide the angle error by the number of sides or the number of angles, and that's the correction. In this case, I needed to subtract. So if I add all these up now, I think I got it. There's 1, 2, 3, 5. Looks like I got, I'm right on. It's perfect. Okay? So I've got angular closure now. Okay, now I can start with a process of moving around this thing in a methodical fashion to get the direction of those 5 sides. Okay, how did we do it? Well, I'm going to draw a line right here too. Okay, there it is. I got it, and hopefully you can see it. Okay, if I look at that picture and I start using my high school math, 2 parallel lines intersected, angles, that angle the same, this angle the same. So if I do that, it looks like I got a number right here that'll work. 5122. Okay, if I subtract 5122 from that 149, 13, 12, that will finish off the angle, and that'll give me what I think I need to fill in. So I'm going to do that. I'm going to take 149, 13, 12. 149, 13, 12, and I'm going to subtract 51, 22 from it. $97. 97, 51, 12.